So just a little background, what is mold? I mean, I'm sure we all pretty much know what that mold's out there. It's not something you want hanging around, but it is necessary for life, and as is a fungi, and it does, break things down, decompose things in our environment, so it keeps life going. But obviously something you don't want, in your house or where you live, to an extent where it's going to cause some issues to the occupants. So being what mold is, a living organism, it does require food, water, and oxygen to grow. Um, it doesn't require sunlight. Sunlight actually tries to, kill it off a little bit. So you'll see dark, damp, moist places. That's where you're going to see a lot of your mold growth issues. Prime environment for it to grow there. So basically, when we're talking about mold, we've got what we have are mold spores, microscopic in nature. It's fungi that grows on the form of hyphae, multicellular filaments. And then these hyphae will form a conglomerate called mycelium. Mold isn't a mobile thing, but the hyphae can grow and extend and reach out to different areas and continue to affect different surfaces. You also may get a scenario where the spores become airborne, which is very common. And if those spores are still viable when they become airborne, they're transmitted through airflow onto another surface. And if you have those ripe conditions, you have the moist environment, you have the food source and the oxygen, it could start to grow on another surface in the nearby area. So even though it's not something like, it's going to move on its own, it can become airborne, disperse around different areas of a room and such, and start growing on other areas as well. And obviously mold's everywhere. It's not something that you're ever going to get rid of completely. Every building is going to have some mold spores in it. You can take air samples in any building. You're going to have mold spores. The thing is to try to keep those at bay, not to have anything more than, really you're getting from your outdoor environment. Allergies in the outdoor environment from mold spores can occur, depending on the season. So if you've got high outdoor counts, mold spores in a certain seasonal area, someone can be affected by that. While inside the building, you might have just as high just because you have that natural airflow and you're still being affected indoors. But that doesn't mean, you have a significant mold issue inside. It's just a matter of you've got air interchange between the indoor and outdoors, and, you have that issue there. So the health effects, a lot of your health effects are going to be pretty similar to a lot of different respiratory problems. You might see flu-like, cold-like symptoms. So it's very hard to specify that these types of symptoms are specifically attributed to mold exposure. You may confuse it with allergies. You may confuse it with a cold or some other respiratory ailment. But if it's something that's occurring in a prolonged period of time, you would expect allergies to die down eventually. You would expect your colds to go away, things like that. So if you have a chronic, these chronic respiratory type issues, that might be a time to look at, okay, is there something in the environment other than that, just regular allergies or cold that's getting to you. So as you can see, allergic reactions, asthma attacks, wheezing, red itchy eyes. So very, very hard to diagnose it specifically to mold. One thing to note, certain molds are toxigenic. They're going to produce mycotoxins, but that doesn't necessarily mean those types of molds are the ones that, if I get rid of those, I'm good. Even if you have some of the more common ones, if they're in a large enough amount, they can produce similar symptoms to people, especially if you have people with immunocompromised systems, or they have a history of allergies or asthma. Those people are going to be a lot more hypersensitive to the mold exposure. Many factors that come into play, but primarily your amount of exposure, your duration of exposure, and then the characteristics or the trait of the person. And the more you become exposed to mold, the more susceptible you may come later in life. So, if you're a child or young adult and you're exposed to mold, you may not see any symptoms at all at that point in time. But as you get older, and you see more, you get more exposure, you may become more susceptible to it. So what are the common sources and causes? Mainly when looking at where you're going to get mold developing from, you want to kind of take a look at the structure itself. The number one factor is your building envelope, where you have that direct contact between your building systems and the outdoor environment, where you're going to have rain, precipitation, humidity, and all those things that can cause moisture or water infiltration. So obviously roof leaks, leaks at windows, doors, exterior finishes, things like that. Your foundation, if you have poor drainage or you have some infiltration to your foundation walls, that can lead to moisture and eventually a mold issue. Or like your additions and repairs, those are common areas where you put, sometimes an addition is constructed on a building. So you've got the old structure, you've got the new structure, you've got all those new place connections where everything connects there. And then if you get some differential settlement on that, you might develop some leaks pretty easily on those areas of additions. So a lot of that depends on how things are constructed, how they're maintained. Something that you can control based on, okay, if you develop issues, okay, what do you do to fix it? Proper repair, proper maintenance, you can control those things. But there obviously is going to be a cost factor. You develop a roof leak, you replace a roof, that's going to cost, or anything like that. So definitely have to be aware of, okay, what do we need to do to take care of the situation? And you got to be cognizant of that cost that's associated with it. Another thing with water infiltration is what's inside the building. Building systems in their fixtures, furnishings, when you have pipe leaks, whether it be your mechanical, if you have mechanical hot water system pipes or your domestic water pipes with plumbing, obviously those can leak at unknown times sometimes. So those things are harder to control, but the main thing, if you do notice it, fix it as quickly as you can. Try to keep any water and moisture leakage at bay, and keep that mold from becoming an issue. Also, your fixtures, your toilets, sinks, tubs, washing machines. If you're in a building where you have water fountains, things like that, those can be a prime area for springing a leak. Refrigerators with water lines. I've seen a basement get totally flooded out when the owner was on vacation and the water line cracked and just leaked all over the basement. One little water line that feeds your refrigerator floods the whole basement out. So there's extensive mold remediation on that project, and just some of those little things you don't think about, especially when you're leaving town. Okay, yeah, everything's good to go. Lights are off. We've got everything's buttoned up. What about your refrigerated water line? You just don't think of things like that. Another thing with water infiltration, things that you can't necessarily control is the forces of nature, hurricane areas, tornadoes, things like that bring water and wetness into a building. You can't really control it, but obviously it's going to be something that would present a problem for moisture and water infiltration and mold concerns. And then you have some other things that are a lot more controllable with human error, but things happen, people make mistakes, and you have to have corrective action for that. One thing would be if wet items are brought inside. So you're outdoors, rainy day, you got wet clothes, you bring them in, you take them off, you leave them in the corner in the bathroom, wherever, laundry room, and those wet clothes just don't dry immediately. So they sit there, they might get other building materials wet. Next thing you know, you have some mold concerns in that localized area. Also, flooding events don't necessarily have to be from natural disasters. They could also be from human error, whether someone put something down the toilet and it overfilled and didn't get taken care of promptly, or you left the faucet on and it overfilled, drained down into below your sink, below your floors, into your subfloor. So that can definitely make a mess in a hurry. So human error is also something you have to watch out for with this water infiltration. Another item I got in there: improper use, placement, or installation of items with water inside. So people might get the idea, let's put a hot tub inside, let's put a a large aquarium inside. But if you don't install them correctly, you don't maintain them correctly, you don't have the right place for them that can control humidity, control condensation, and all that, you're just asking for a disaster there. So, whenever you get the idea of doing something like that, you want to make sure that you have everything under control, and the area that you're putting in is properly set up to handle that. Another common source, humidity, limited ventilation. A lot of this is going to depend on the region where you live or where your building is. Certain areas of the country are going to have a lot more humid days than others. So if you're living in those conditions where you have high humidity over an extended period of time, you definitely want to have buildings that are properly air conditioned and can reduce that humidity level inside and maintain it at a reasonable level. So ideally, you're looking at a relative humidity somewhere in your 30 to 50% range. Those are ideal conditions. You get too low, it becomes a comfort issue, dry skin, chapped lips, things like that. So you don't want to be too low. You want to have a little humidity, but you don't want to be too high either, because the high humidity is going to get that mold growing. Once you get around 60, so 30 to 50% is ideal, but definitely try to keep it under 60%. You get above 60, and those are those ideal conditions for mold to grow. So if you do run dehumidification systems and units, try to get that down to that, maintain it below that 60% level. So problem with high humidity is usually it's coupled with limited. If it's coupled with limited ventilation, that's where you get some serious issues. So if you have an attic area, so to speak, and it gets humid up there and there's not proper ventilation up through there, you're going to see the your wood materials, your roof decking materials. You're going to see mold, mildew start to grow on those because you have that limited ventilation, you have high humidity conditions. So if you're able to increase that ventilation, that helps because you're cycling that air out, you're cycling the moist air out, you're bringing fresh air in. Ideally, it's going to be conditioned air so that you're not bringing in more humid air. You're bringing in conditioned air so you can keep that cycle going, and then make sure that you're getting the high humidity air out and lower humidity air in. So you'll see a lot of this in abandoned buildings. Once you shut down that heat system, that HVAC system, you're not conditioning your air. That's really the prime time for mold to find its way in, because you have those moisture humidity issues. Another source, condensation. So condensation, basically when your water vapor becomes a liquid, you got warm air colliding with those cold surfaces, and then you get the water droplets forming on those cold surfaces. And that all occurs due to your dew point temperature. So that dew point temperature here, as you see, is temperature the air needs to be cooled to in order to achieve a relative humidity of 100%. So your air becomes saturated, that water vapor needs a place to go and form water droplets, condensate into liquid form rather than vapor form, and that's when you get an issue with condensation. Your materials in the building become lower than the temperature of the dew point temperature, and you get water droplets forming on those. So as you can imagine, probably you're aware of seeing them in different scenarios, glass, metals, things like that, which are naturally going to have a lower temperature than other materials. You see the condensation on those types of surfaces first. And it may not be an issue with mold growing on glass or metal, but those water droplets, say you got a window unit and you got a wood frame. Well, those water droplets are eventually going to make and obviously your wood frame is going to be a little bit more susceptible to mold, and that's where you're going to see some mold, mildew type scenarios crop up. Some things that occur inside the building, can affect your condensation. Washing, cooking, bathing, that's going to increase the water vapor in the air, so you're going to have a higher potential for condensation during time periods when you're doing those activities. So obviously, if you have exhaust fans, use them appropriately. Make sure they are on when you're doing the washing and cooking and bathing and all that. It does help to pull that air out, recycling better air so that you can prevent the condensation or reduce the potential for it. Another source, plants and soil that you might have indoor plants. Indoor plants are good to an extent. You might have one or two plants in a room, in an office, in a bedroom, things like that. That's good. It helps CO2 levels and all that. But you get to a point where you have 10, 12 plants in a room. That's probably not a good scenario because you got a lot of these living plants in your area that can have decomposing leaves. They can have issues with the soil and all that. And when you're looking at plants, there's a lot of sources for which mold can grow or fungus can occur with those plants. One being overwatering. So if you overwater a plant, all that excess water is just a good source for mold fungi to soak up and grow. If you have poor drainage out of your plants, if you don't have, some holes in your pot, your plant plot, so that the water can flow out, excess water can flow out, then it just creates that breeding ground there. Also, decomposing leaves on a soil surface. If you don't clean out the dead leaves every now and then, those can decompose, create a mold growth issue. So you want to keep an eye on those plants if you do have them in your indoor environment. So as far as once we do have, if we do have a source, where do we typically see some mold issues? Commonly, we're looking at locations that aren't readily exposed to view. You don't see them every day, out of sight, out of mind. Things happen behind a wall, above a ceiling, down in the basement, up in an attic. You're not really looking for it every day. Or areas where you're not routinely cleaning or maintaining. You might have dust, debris, so a little more food source for mold to grow. Or you get mold spores in an area, you clean them up routinely, you might not have an issue. If you don't clean them up routinely, you get a little dampness, then you have an issue. Or areas with poorly conditioned air. That's very common as well. You don't have that good air circulation. The humidity builds up at different periods of times. You get the issues with mold, the potential issues. So we're looking at pipe chases, wall cavities, attics, basements, crawl spaces, mechanical rooms. Those not only are they maybe not necessarily cleaned and maintained all the time, but also they're warm. If you got a boiler system, your furnace system, they're going to produce heat. So now you got high temperatures. If you introduce some water, condensation, humidity, and whatnot in there, you got some good breeding ground for mold. Bathrooms, obviously, kitchens, obviously, you have the water sources, you have the tubs, sinks, toilets, you have all that, where you have the moisture right there. And then windows and doors, a lot of times with the condensation effect, if you don't have good insulated areas. So that brings us to question number 1.
Cheyenne, please continue.
Okay, question number 1 was true or false, condensation will occur on a material surface when the temperature of the material increases above the dew point temperature. That is false. It's when the temperature is below the dew point temperature. All right, so when we look at trying to control, mitigate mold, or we have general concerns with mold, where do we look to address these issues? What guidelines do we have available to us? On the federal level, that there's a lot of different agencies that have prepared different guidelines for mold-related effects. OSHA has some worker employee protection type scenarios, so they have guides for mold. EPA has some guidance. You know, the IICRC, Institute of Inspection, Cleaning, and Restoration, and certification, they have some guidelines. New York City Department of Health, they're one of the first to actually come out with guidelines as far as, you know, addressing mold in buildings. So, you know, a lot of things that they were a precursor to a lot of other guidance that came out after that. But what you see on the federal level, it's a lot of guidance, you know, just providing some helpful information for the end user to try to, you know, keep mold becoming an issue, try to protect themselves. There's nothing set in stone. There's no regulations that say this is what you have to do. This is the standards you have to clean things up to. There's none of that, and there likely never will be. It's just a sort of thing where, you know, being that mold is everywhere, and you know, in New York State, your mold levels and distribution is going to be a lot different than what you would see in Texas or California. You can't have a consensus as far as, you know, what's safe, what's normal, what's not normal. So the best thing to do is there's guidelines out there. If you see mold in a house, if you see mold in a building, take care of it. You know, get rid of it. Try to keep it at bay. Try not to have mold in a building. That's the number one priority. So on the state level, we do have mold legislation in New York State. Again, you're not going to see anything in this mold legislation that tells you exactly what you have to do, exactly how you have to do it, or tell you specifically what standards you have to meet once you're done. What it's going to do, what it does, is three main components: training, licensing, and minimum work standards. It says if you're going to hire someone to do mold remediation, you know, as a consumer protection type legislation, we're going to make sure we have, you know, some teeth to make sure that those firms are trained, they're licensed, and they're meeting some minimum work standards. So again, like I mentioned, this was a consumer protection type legislation. It's basically out there to protect the end user who hires someone to do mold remediation specifically, to keep them from getting scammed, to keep them from getting some contractor come in and not really taking care of the problem and just moving on. So at least if they've got some training, licensing program in place, they know that the firms at least have had the training, licensing, and then they can at least say, you should know better, you should have done a better job, you know, this doesn't meet the minimum work standard. So with that, the New York State mold legislation defines a mold project as mold remediation, mold assessment, or mold abatement of areas greater than 10 square feet, but it does not include routine cleaning or construction, maintenance, repair, or demolition of building structures or fixtures undertaken for purposes other than mold remediation or abatement. So what that all means is, if you're hiring someone to do specifically mold remediation or mold assessment, this legislation applies. If you're doing a renovation project and they happen to find mold in there, this doesn't apply. The contractor can remove that mold. It doesn't have to be a licensed contractor. They can remove it. They can continue on with the renovations. This doesn't really apply. You can write into a project that you would want it to apply, and you still follow all these requirements, and that's fine. But, you know, just in the run-of-the-mill things, this legislation only applies if you're designating the project specifically for mold remediation and hiring someone to do that. So when we talk about the minimum work standards, they define minimum work standards for the assessment, the remediation, the post-remediation clearance. So on the assessment side, really the end goal is to have a mold remediation plan. The mold assessor does your assessment, so they're licensed as an assessor. They come out, they look at the area, they do the visual, they do the full assessment, and they come up with a mold remediation plan to give the owner to say, okay, this is what should be done to address the mold that we have here at this building. So the mold remediation plan, the components you see here are the minimum requirements of that mold remediation plan. The assessor has to identify the areas of work, the estimated quantities, the methods that should be used to remediate each area of impact. It should suggest the PPE that should be used. So if you need, if the assessor feels that there's a need to have respiratory protection when dealing with it, they should state that as such. Proposed clearance. So what do you do at the end? How do you certify that the work was done? The assessor needs to identify how that goes down. Notifications, how do you notify building occupants? Again, none of this is, there's no set, okay, well, you have to notify the occupants 10 days in advance, all that. That's the assessor's call. They could say, well, let's notify them 3 days in advance. And how do we do that? Well, we're just going to put a sign up on the door. That's part of the mold remediation plan. That's what needs to be done. Also, an estimate of the time and cost to complete the mold remediation. If you can identify the underlying source of moisture, that should be in the mold remediation plan. This isn't a requirement. It isn't, you don't have to go out of your way as a mold assessor to look at every little nook and cranny to identify what the source of moisture is. But if it's obvious and it's clear and you can identify it, they do expect that to be told to the owner. On the remediation side, minimum work standards there. They have to prepare a mold remediation work plan. So this is different than your mold remediation plan. This is the work plan that the contractor sets out that they're going to follow. So what you're going to see a lot of times is they're going to create a work plan that pretty much mirrors what that mold remediation plan has. That way it's a seamless transition. You're not going against anything that the assessor thinks needs to be done. But they may also add some things in, like, okay, we'd like to use this on top of what the mold remediation plan says. So that's usually fine. It's when you get into them coming in with a work plan that doesn't fully meet the criteria or the minimum criteria in that mold remediation plan. That's when you might have an issue that the owner might want to say, hey, you're not meeting what the assessor wants to do. We need to have a discussion as far as what you're actually going to do here and if you're the right fit for the job. PPE, they're going to specify what they're going to use for PPE. Again, it should follow the minimum what's in the mold remediation plan, but they may want to use more for their employees. If the mold remediation plan didn't call for respiratory protection, maybe the abatement contractor says we want to use respiratory protection. This is what we're going to use. So, and that's fine. They're going to specify the type of containment to prevent the spread of mold, and they're going to maintain that containment until there's satisfactory clearance. Signage, display signs to advise of a mold remediation project is in progress. And then also in the legislation, there's some stuff about use of disinfectants, biocides, antimicrobial coatings, and all that. The main thing with this is the DOL specifies in their legislation they only want these things used if it's specified in the mold remediation plan, and only if it's registered by the EPA for the intended use, and only if the use is consistent with manufacturer's label and instructions. So you don't want to bring in some product that isn't registered by the EPA. Nobody knows if it might have harmful effects outside of cleaning mold. Basically this is a protection as far as what they're going to use in your building. It's a relatively safe product, and it's not going to cause any more harm than the mold already is. Then also on the work standards, minimum work standards, there's a minimum work standards for your post remediation assessment and clearance. Obviously, you want to determine whether the area is free from visible mold. That's the end goal. We want to get that mold out there. But also make sure determine if that work has a complete compliance with your remediation plan. So it's not only, okay, let's take out materials of mold and move on. The remediation plan may say, okay, we're going to take the materials that are obviously visually impacted, but we're also going to clean the area. That's typical. So I want to make sure that they did go ahead and clean the remaining surfaces. We don't want to leave those dirty and tear down the work area and move on. So that's going to be all part of your post remediation assessment. And to the extent feasible, you want to determine that the underlying cause has been remediated, or make a recommendation as to the type of contractor who could remedy. So again, the whole intent of the mold remediation program is not specifically to assess and address the source of the moisture. That is the ideal situation, that you can kill two birds with one stone. But it's not expected that a mold assessor or mold remediation contractor is going to be qualified to go ahead and fix up and patch and repair any of the mold sources. So if you have a roof leak, they don't expect the mold remediation contractor to be a roofing contractor to go up there and fix the problem for them. That might have to be something that's done after the mold remediation. And then finally, issuing a written past clearance report. So they have that documentation that it was observed, it was reviewed, it does meet the criteria that was specified. All right, now question number 2.
Please continue, Cheyenne.
Okay, question 2. Article 32 of the New York State labor law defines a mold project for affected areas greater than what size? Per the definition, that is 10 square feet. Answer B. All right, we have question number 3 as well.
Please continue, Cheyenne.
Okay, question 3. True or false? Mold remediation work plans are prepared by licensed mold assessors. That is false. It's the mold remediation plans that are prepared by the assessors, and then the mold remediation work plans are prepared by the remediation contract. All right, so going back to the mold assessment, some of the things that can be done during a mold assessment, the minimum things that need to be done are your visible observations. Obviously, if you see it, you need to identify it. Visible water sources, if there's an obvious leak or water infiltration, moisture issue, identify that. And then, looking at the bill of materials that are impacted and identifying the locations and the size of those impacts. Some additional things you might do during a mold assessment is utilize some different technologies and resources, such as moisture testing, infrared camera, particulate monitor, destructive assessment, where you're actually removing some materials, getting in behind wall cavities and such to get better observation, and then possibly sampling. So none of these things are specifically required, but they do have their value in certain scenarios. You do have to know what you're getting into, or what you're looking at. Sometimes with moisture testing. So with moisture testing, for instance, it's not like you can just go out and get a meter to test every different material in a building. They're really only set up for certain materials. So gypsum board, you can test wood, you can test concrete. Basically, you got to have a baseline to compare it to. So if you have a material, you can't go plug it into a ceiling tile and say, okay, we're going to be able to compare it to a baseline level. There's really nothing out there for that. But like gyp board and wood, you have those levels you can compare to and see if they're, in a what you consider a dry condition or a condition that wouldn't promulgate mold growth, or if they're in a wet condition where if you have an issue with mold, it could continue to be a source of a problem. Infrared cameras, those are sometimes useful if you understand what you're reviewing, what you're looking at, and the data, and you know how to properly filter through that data and make a judgment as far as whether or not you have some cold spots that could be issues for moisture or condensation. Sampling, all the regulations, guidelines, sampling is not a requirement. It's not even a recommendation a lot of times. What it is good for is, a little bit of comfort to the occupants or the owner that, okay, yeah, let's take a look and see what we have for this discoloration that we see on the wall. Is that mold? you know, a mold assessor could probably look at it and say, nah, it's not mold, it's this or that. But, you know, sometimes it's comforting to know that we took a sample of it, we had it analyzed, and here's the results. And as expected, it's not a mold issue, or lo and behold, it is a mold issue. Then you look at air sampling again. You know, nothing that's really required or recommended, but, you know, comfort of the owner, occupants. Okay, what are we breathing in? You know, this could be, you know, doing an air sample could be good and bad, but you know, definitely you have to know what you're looking at. It's kind of it's a little bit subjective in that you're usually comparing indoor results to outdoor results. But if you're sampling during like colder months, your mold spores outdoors could be pretty low, and you could have higher mold spores indoors. And you know, to the lay, you know, to the layperson, that may look like an issue, but to someone who's done the air sampling a lot and it's still relatively low levels, and we're not seeing any mold, it might be a non-factor. So you really have to know what you're looking at when you do the sampling or you commit to the sampling. So here's some sample data. So this is a project we did some air sampling at. And you look at these, and you know, you definitely have some higher levels than your outdoors. But all in all, these are, you know, for the types of spores, these aren't screaming high. You know, less than 500 on some types that are pretty common, or your 900, 1200. That might be a little bit of an issue, but you're not too much higher than the outdoors. What you do notice though, is you gotta kind of this is a scenario where you kind of take a look at the type of mold you're dealing with. So the stack of buttress, you know, this is present. The problem with this is it shouldn't be indoors at all, really. And you don't really get it outdoors much at all either. So when you do see it on an indoor air sample, it kind of raises a red flag that, you know, we're seeing this. Usually this comes from something that's been wet for a prolonged period of time. It takes a while for this mold type to grow. Seeing that in the indoor air, not a good sign. There's probably something going on in there that you want to evaluate a little bit further. But if you looked at this and you said, okay, well, 13 and 53, that's not much higher than less than 13, not an issue. Well, it's an issue because of the type we're dealing with. So again, looking at your air sample results, you want to make sure you kind of know what you're looking at before you just go out and carte blanche, make some judgment calls on it. Your tape lift samples, this is where you would actually take a piece of tape, transparent tape, put it on the surface. You put that in a Ziploc bag, send it back to lab. They put it under a microscope. It's not a scenario where they could, you know, they're going to go and give you counts like they did on the air samples. They're basically going to give you a qualitative analysis on that. So is it, you know, different mold types were they not detected, or light levels, moderate levels, heavy levels detected? Something like this, you might see light levels and say, oh, I got mold. Well, you're going to get mold. Again, mold's going to be present anywhere. You know, you can have mold spores that just naturally settle on surfaces. Those light levels, unless we're dealing with something like Stachybotrys, so not here, but you know, basidial spores, other identified. You know, these types of things, you see light levels, okay, probably not a big deal, especially if we're not visibly seeing any discoloration or anything to that effect. You start getting into the moderate or heavy levels, then you start questioning, okay, we probably have an issue. And chances are, if you took a sample and it came back heavy, you probably saw the mold there to begin with. You're just kind of confirming what type you're dealing with. All right, question number 4.
Please continue, Cheyenne.
All right, which of the following is not required as part of a mold assessment per Article 32 of New York State labor law? So that's our mold legislation in New York State, and that is, the answer is C, sampling is not required. So mold remediation. So now we get into the mold remediation. So how do you do it? What do you do? Generally, you're looking at trying to contain a work area, trying to limit it from spreading during the removal and cleaning, and then you're either cleaning surfaces or you're removing and replacing surface for eventual replacement. Now, when you look at how you contain a work area, there's several options. You can have no containment if it's a real small localized area. You can kind of, just contain the source where maybe you put a piece of poly over an affected piece of sheetrock wall, gypsum board wall, and then you cut outside of that poly, you take it off and throw it out. So that would be a scenario if it's a small localized issue, no containment, it's probably satisfactory. You get into some larger areas, you might go with a limited containment where you're just putting up a single layer of poly, maybe a pop-up tent, doing your work, cleaning, clearing, tearing down the tent and moving on. Or you got a real big issue, you're looking at a full containment system, something you might liken to a containment for asbestos abatement where you have 2 layers of polyethylene sheeting, on the different surfaces that aren't affected. Putting in a negative air machine to filter air out and all that. So you can really have a full gamut of different containment systems depending on what you're dealing with. And then when you're looking at, so if we got containment, like I said, the negative air, you might want to put your work area under negative air pressurization. So what that means is we're just making sure that there's you're going to go from positive pressure to negative pressure, make sure your work area is under the negative air so that if there is a breach in your containment, it's going to try to pull in air from the outdoor instead of pushing air from the contained work area to other non-contaminated areas. Another option is air scrubbers. So those differ in negative air machines in that they basically would sit in a work area and they would filter the air and recirculate it in the work area. So you're bringing in the contaminated air as you're remediating, you're putting it through a filter system, you're recirculating out as cleaner air, and you just keep cycling that through. Whereas your negative air, that's actually ducted through out to pretty much the exterior environment, so that you're pulling air in and you're filtering outdoors. So the negative air is obviously going to be a level up. It's a better scenario, but if you're just dealing with a small limited area, you don't want to, you don't have options possibly to get negative air to the outdoor environment. You might just go with an air scrubber type situation where at least you're filtering the air as you're remediating. Also, dehumidification equipment might be very useful during your mold remediation. If the issue was a humidity problem and you don't want a situation where you're trying to remediate materials and you still have high humidity, that's no good because it's just going to decide to grow back elsewhere. So try to dehumidify it while you're remediating and then keep it dehumidified after. Keep those humidity levels low afterwards. So the methods and treatments, a lot of what you'll see is cleaning, remediating those surfaces. Sometimes you can do a disinfectant that will help. Sometimes you just have to remove the material. So if you're talking those porous, absorbent type materials, gypsum board, sometimes your wood materials, carpeting, the easiest thing, get rid of them. It's going to be very hard to clean, and even if you can clean, there's no guarantee it's not going to be an issue, a recurring issue. So a lot of times you're left no choice but to remove and replace. But some surfaces you can do a cleaning where you soap water, or detergent water or some sort of cleaning chemical, wet wipe, damp wipe, HEPA vacuum. Once you do your wet cleaning methods, obviously you're going to want to try to make sure those surfaces dry in a reasonable time frame. So you might have, mechanical drying methods inside your work area to dry those out after you clean them, keep them from staying wet and moist. Abrasive methods, those will be useful for if you have some issues on concrete. Now, you're not going to have, mold's not going to grow directly on concrete, but if you have a dirt and debris on your concrete surface, it can obviously grow on that. So you might have to use wire brushing, sanding, get that off there. Or if you have wood joists or structural wood materials that you can't remove and replace, you might use an abrasive type method for that, sanding or media blasting to try to move material from that wood, so you can keep that wood surface. A lot of times what you'll see, try to get the surface mold off the structural wood, and then if you can get it to a point where it's in good condition, then put a sealant on it, so that hopefully later on that'll prevent any further issues on your structural wood framing. The post-remediation clearance, went over this a little bit earlier, but doing a visual, that's number one. You got to do a visual. You may do some sampling, you may do some moisture testing, and you want to look at, have we eliminated or mitigated that moisture source? If the mold remediation contractor was able to do that work themselves and you can mitigate that's great. But if not, you're letting the owner know that, hey, we got the mold remediation, we got the mold done today, but you still have this water source that you got to take care of, and the sooner the better, or you're just going to be back to square one. So ultimately, the best thing to do with mold is to try to prevent it in the first place. And how you do that, it really is a combination of design, construction, and then building operations and maintenance. If you don't design a structure well enough to keep water issues out, you're just going to be fighting it the whole duration life cycle of that building. And if you don't construct it the way it's designed to keep that water out, again, you're still going to have issues. And then obviously there's the end user. You got to operate and maintain your buildings, or it doesn't matter how well you design or construct. If you're not maintaining it properly, you can have issues. So when we talk about designing to limit mold, there's a lot of different factors that come into play. It all starts here at the design phase, but obviously site selection. You want to avoid flood zones. If you build in flood zones, you're just asking for problems. You might have to backfill to raise your elevations to get those the elevation of your structure higher than the water tables and things like that. And then your structure types and features. You want to consider your local climate and environment. Is it a rainy climate? Does it have snow, ice, where you might have ice dams on your roof? You might have different parameters you have to design to with those situations, and you want to make sure you meet those parameters so that you don't have issues with water and moisture. Foundation drainage, make sure you have good perimeter drainage, waterproofing. You don't want water to enter your foundation if you're in a high water table condition. You may also consider not having the basement areas with high water table. Obviously, if you don't have a subterranean floor or subterranean basement level, you're probably not gonna have drainage issues into your living environment. But if you have that basement, you have a high water table, you don't have proper drainage or waterproofing, then that's gonna be a problem. Sloping away from the foundation, that's very critical. You don't want ponding, pooling, standing water right upside your building. So good slope away from the foundation. Gutters, downspout, splash blocks. Often, these are often installed right out of the gate, but maintaining them kind of goes to hell sometimes. So you do want to make sure you have those things in place to direct water away from your building. You could just imagine, a little bit of water can do a lot of damage. You take a cup of water, you put it in a glass, you hold it in your hand. Doesn't seem to be a lot, but you spill that on the floor, you got quite a bit of a mess to clean up off the floor. Now you take that same cup of water and you try to squeeze it through cracks and fissures and different things in the building. You can just imagine how many surfaces or the square footage of the surfaces that water will eventually touch. And, that's all prime ground for mold to develop. Avoid plantings within the first 5 feet of the structure. So, not only do you have concerns with the roots themselves that might damage your foundation system or your structure that could eventually lead to water infiltration, but also those plantings, they're going to provide shade. The sun's not going to dry that land out as quickly as other areas. So if you do have heavy rains, that water is going to sit there. It's just going to want to find a way to go. And if the easiest path to go is towards your building, that's where it's going to go. So keep your plantings a little bit away from your structure. That's always good. Building enclosures, you want to design those such that surface temperatures within the assemblies are above the dew point temperature. Again, it all rests on that dew point temperature. So you got to kind of have idea what you're dealing with on that. Insulation, you know, minimum R values by code, make sure you meet those. There's a reason they have those in there. So make sure you insulate properly to keep you know, those cold spots away. Air barriers, vapor barriers, make sure you have appropriate air barriers and vapor barrier systems. Make sure you're putting them in the right locations, or designed to be placed in the right locations. You know, improperly positioned vapor barrier can have just as much detrimental effect as not having one at all. So make sure it's in the right location there. Capillary breaks keep water from wicking into a building. So not only do you have to worry about water leaking into a building with certain materials, you're gonna have to worry about capillary action, water wicking up into your, you know, concrete block, wicking up concrete block, and then creating a moisture issue inside. So make sure you have good capillary breaks there. Watertight systems, roof flashings, window flashings, sealants. Make sure those are in the design so you can seal those up nice and watertight. Some other items: appropriate roof pitch and overhangs, especially if you're dealing with, you know, a climate that has snow. You want to make sure that you don't have too flat of a roof. That snow is going to sit there. You might get ice dams, things like that. You can't properly direct that water away from there. Ventilation, exhaust, kitchens, attics, bathrooms, good exhaust. HVAC system, make sure it's designed to properly control humidity, both in your heating and cooling modes. You could have issues either season, so make sure your HVAC is good. Specify moisture tolerant materials where applicable. So when you're dealing with like a basement scenario, it's probably not the best idea to put in those carpets and things like that on a nice concrete floor, especially if you're below that water table. You're just creating a scenario where you could have some condensation below your carpet and you not even realize you have an issue until you peel that carpet off. So those types of scenarios, you're gonna probably want some tile, or leave the concrete, let it breathe, things like that. Limit the use of absorbent type materials. Avoid or limit carpet in general. Carpeting is nice, it's comforting, it's all that, and you know, maybe it's good for a bedroom where you know, you're walking barefoot, things like that. But you know, you put carpet in where you're entering in and out of a building, you get dirt, debris, moisture from that. You put it in a basement area, you got moisture there. Definitely don't want it in a bathroom, kitchen, things like that. So avoiding and limiting carpeting is a good thing for preventing mold. Then using appropriate floor materials for areas near doors. So no carpeting, wood materials, probably not a great idea. Get something that, you know, you can, the water might, you know, set on, it'll bead, you can clean it up. Not gonna be an issue. Make sure you use floor mats, things like that. All right, constructing the limit mold. First and foremost, it's very important during the construction phase that the design parameters are understood. So you understand the intent design features related to moisture water control. This isn't always satisfied, but the more the contractor is in tune to why they're doing something, the better off they're going to be able to install it, and more successful it's going to be. So that is a key component that may often be lost. Appropriately, you know, and then just doing the construction itself, make sure that slope and grade works out the way it needs to be. Properly install your specified materials. Don't, you know, if you know, there may be some other alternatives, but you know, make sure the designer's aware of scenarios where you might want to use something different and they approve of it, because there may be a reason why they specified a certain material. Avoid cutting holes in air barriers or vapor barriers. This might be a common issue if you have say a sub-slab vapor barrier, especially when you're placing concrete. You have a little extra water from your concrete. You know, sometimes you're compelled to cut a hole in that vapor barrier just to let that water seep out and below the vapor barrier. That's not a good idea. Now you're creating that avenue for moisture to come up, and it will find that one hole. You don't think about it when you're constructing, but you put a hole in a vapor barrier, vapor's going to find its way up through there, especially since it's easier to come through there than it is to go through the subgrade below. Don't install materials that are wet or damp. Definitely don't enclose materials that are wet or damp. So if something gets wet during the construction phase, make sure it dries out before you install that. You don't want those headaches afterwards. And then also inspect, test, repair during construction process. You got to continually have diligence and make sure that you're keeping things in a sound condition. The final phase of the process, maintain the limit mold. Again, when you're maintaining a building, you want to understand the intent of those design features. You want to understand how things are constructed so you can properly control water and moisture. You want to do regular inspections and O&M, so that involves your HVAC, your plumbing, drainage, all that, attics, basements. Inspect those, have a periodic inspection schedule, make sure you don't have any water issues. Any cracks that might develop, seal those up, seal any openings up. Sometimes certain surfaces you want to paint or seal, have a mold inhibited paint or mold inhibited sealant that will help your scenario or situation there. Keep your bill of materials dry, mitigate. If you do have a water issue or leak or overflow or something like that, make sure you try to get that taken care of within 24 to 48 hours. Once you get past that 48-hour mark, that's when your mold starts growing. So try to clean it up immediately. Dehumidifiers when applicable. Storage of materials. If you're in a basement area that's a little bit damp throughout the year, or you have a dehumidifier in there to try to control humidity, not a good idea to put absorbent materials down there. You don't want to be storing, probably don't want to be storing cardboard, papers, things like that, because they're just going to soak up that moisture and create mold. Reduce clutter in general. If you have a lot of things in a room up against walls, you're creating locations where you could get condensation, dark, damp locations. Routine cleaning ducts and vents. Fireplace dampers, keep and closing that in use. And maintain your vegetation slope around the structure. Make sure things don't get out of control. Or your gutters and all that. Make sure everything's in good working order. So with that, we have question number 5.
Please continue, Cheyenne.
All right, so question 5, true or false, per Article 32 of the New York State Labor Law, a mold project must include elimination and mitigation of the source of water and moisture. That is false. It's ideal if they can, but not a specific requirement for the mold remediation folks. So that is the end of this presentation, and it also concludes our fall webinar series. We will be having one in early 2022, so look forward to that. With that, if there are any questions on this one, please submit those in the chat feature, and we'll look to answer those for you.
And there are no questions, so that will conclude our presentation for today. Thank you everyone for joining, and enjoy the rest of your day.
Okay, thank you.